This is question 13 and it's a question about graphical inequalities, and it says that on the grid show by shading the region which satisfies these inequalities. So x is greater than or equal to 0, x is less than or equal to 2, y is less than or equal to x plus 3, and 2x plus 3y is greater than or equal to 6. So we can start by drawing the lines which would represent each one of those if we replaced the inequality by an equals. And an important thing is as well, if the inequality is a greater than or equals or a less than or equals, then we represent the line as a straight line, solid line. Whereas if we had just a greater than or a less than, we'd actually represent that as a dotted line. And that shows that the region we're interested in doesn't include the line. So I'm going to start off by drawing x equals 0 as a solid line because it's got the equals to as well as the inequality. So if I do that, that's a line which is just basically the y-axis. So I'm going to draw that there. And then I'm going to go to the next one. And this is x is less than or equal to 2. So I'm going to draw x equals 2. And that's just a vertical line that goes through 2 on the x-axis. So it's just a line like this. And again, we draw it solid because we've got the equals to as well as the inequalities there. Next, we've got y equals, or y is less than or equal to x plus 3. And so what we can do, we can draw the line y equals x plus 3 first of all. And again, a solid line because the inequality is less than or equal to. And one thing we know, if we consider, in doing that one, if we consider y equals mx plus c, the equation of a straight line, we know that the c is the number that's tagged on at the end. So if we compare it with y equals x plus 3, that's the y-intercept. So that tells me that this line is going to go through here at 3. And also that the gradient is the number multiplying the x. And we can see that because there's nothing written there, it's actually 1. So the gradient is 1 for this line. And that means for every one across we can go up by 1. And then across by another one, up by 1, across by 1, up by 1. So that's the equivalent of having a gradient equals 1. So I'm going to draw a line through those points as well. There we go. So that's our line y equals x plus 3. I should just label these actually. This is x equals 2 and this one is x equals 0. And so finally we're going to try and represent this one. So that is that 2x plus 3y. So this says greater than or equal to 6. So first of all, we're going to just draw the line equals 6. And a very useful way of doing this is to decide what the values are when it crosses the axes. And we can do this by, if we decide to look at the case when x equals 0, then we can see that the first part would disappear. We could cover that up and we'll be left with 3y equals 6. And so y would equal 2. And this will give us the point where it crosses. So this is the value when it crosses the y-axis. So I can put that as a cross there. So that's one point that the line's going through. And because this is a straight line, we only need one more value. So I'm going to also look at the case where I'm going to now make y equals 0. So this bit will disappear. So when y equals 0, we'll actually be crossing the x-axis this time. That would mean that the equation is going to be 2x equals 6. And so x would equal 3 if we divide both sides by 2. And that's the point where it crosses the x-axis. So that gives me a point here on the x-axis, and I can join these two lines up then. So that's the line 2x plus 3y equals 6. So now I'm going to look at the inequalities and decide where I'm going to shade in. So we've got to shade the region that satisfies all these inequalities. So first of all, we know that we are to the right, because we're greater than, of this line, because this line was x equals 0. So because we're greater than that, x is greater than 0, we're to the right of this line. And also, x is to the left, because it says less than, the line x equals 2. So we're to the left of this line. This was x equals 2. I know it's getting a little bit complicated, this diagram. And then we can also then look at this one here. The third one is saying that y is less than x plus 3. Well, since this line is y equals x plus 3, if y is less than that, we're going to be below that one. And then finally, we've got that 2x plus 3y is greater than or equal to 6. So that means greater than, we're going to actually be above this line, because this is the line 2x plus 3y equals 6. So if we shade in the region that satisfies all those conditions, that's actually going to be here. This is a trapezium, actually, the shape, because we've got two parallel sides at either end. And I'll just make the point again that these lines are solid lines because all our inequalities actually had the equals bit as well. If they didn't have, we'd have actually represented that region as a series of dotted lines to show that the shaded region didn't include the line itself. For the next part, we're told that we've got a region S that satisfies these following inequalities. So y is less than or equal to 4x, x is greater than or equal to half x, and x plus y is less than or equal to 6. So it says that Jeffrey says that the point with the coordinates 2, 4 doesn't satisfy these inequalities because it doesn't lie in the shaded region. So first of all, I'm just going to plot this point here, and that's the x coordinate first, so that's the 2, and that goes there. So that's that point on the line. Is Jeffrey correct to say that it doesn't satisfy these inequalities? So the thing is, because we're actually including the line, because it's also got the equals to, so in this case x plus y is less than or equal to 6, it includes the line. And this line here is the one that is the x plus y equals 6. But we include the line because the inequality is less than or equal to. So we can say that Jeffrey is incorrect because the inequality is less than or equals and includes the line. So I hope that's been helpful to you, and if it has, please consider subscribing to our channel and also giving the video a thumbs up. Thanks for watching.